Hey, topping your life's math and history, and we are going to take a look at gear ratios. But before we start, we have some surprise for you. So, what we have right here is a puzzle that I made out of Vex Robotics parts. It's called the reverse gearbox theorem. So, it has 4 gears, one small, one big, and one small. So the question is, if I turn the gears, will the mechanism go faster or slower? Type in the comments below so we can reveal it before the video ends. But it'll help us to understand gear ratios to find out and solve the riddle out. And when you think of gear ratios, what do you think of? Well, yeah, you probably think about these gears or these gears. Or sometimes gears like these.
Trying to turn back time. If I can just reverse the polarity.
Good job. Quick thinking, Holly.
So yeah, that's probably what you'll think about. But what if I told you that we can calculate how fast gears spin using mathematics? Yeah, that's right. What we're gonna do is sort out these gears and see how fast and how much torque they would have if we compare one to another. So there are 2 types of gear setups. There is a gear reduction and a gear overdrive. So what we're going to do is understand which of the following gears represent which gear setup. So let's get started. So here's the first gear setup. So we have 2 gears. One is green with 60 teeth. The other one is red with 84 teeth. And we are going to say that we're going to label the green gear as our drive gear. That means that if this setup was in a machine, then the green one would be attached to a motor. Oh yeah, and that is a Vex Robotics motor. So if the green gear was attached by a motor driving the red one, while the red one is being driven by the green one, how many times will the green gear go as well as a relationship as the red gear? So that's why we're going to calculate gear ratios, because it calculates how many times a gear rotates with a comparison with another. So to what it looks like, there's an actual formula that would help us understand how this all works. So the gear ratio can be calculated when you have your driven gear, divide that by your drive gear in terms of how many teeth the gear has. We already said that the red gear is being driven by the green gear, which is attached to the motor. So what we're going to say is the red gear has 84 teeth. And we have to somehow divide that into the green gear, which is the drive gear attached to the motor, is 60 teeth. So what we're going to do is understand, hey, there's a fraction right there. But the problem is, fractions are ratios, but we need to find a better, clear input, like a better format of how we do this. So, you know how we turn fractions like 1/2 to say 1/2? Like the score of a football game is like 1-2? Well, we can actually do that with gear ratios as well. So what we're going to say is 84/60 as a gear ratio. But hang on, this totally makes no sense because we still need to simplify this out. Who wants to use math with complex numbers? Not me. So what we have to do is simplify it out. What we can do is divide them by some kind of common factor and get what we can get, a simple fraction. So 84 and 60, we can say that they're both divisible by 12. So we're going to simplify them, because 84 divided by 12 is 7. And 60 divided by 12 is going to represent 5. So what that is telling you is the gear ratio says 7 to 5. That is explaining that every time the green gear turns 7 times, the red gear is going to turn 5 times. So that means that if I put a point where the two gears are touching, once the green gear turns 7 and the red gear turns 5, that same point that I placed will be at the same place where the gears mesh with each other. So that is going to represent one of the two gear setups. What is it? Correct. Yes, it's called a gear reduction.
Bong! Gatutu!
It worked! The ship's stopping!
So a gear reduction happens when the gear that is attached to the motor or the drive gear is going to be meshing with a much larger gear. This is useful because sometimes machines need to get more power. So gears do transfer energy by rotating with teeth, but not only that, they transfer torque and power. We said earlier that this spins 7 times, so that turns 5. That is saying that even though the machine is slower, it's going to be a lot more powerful, meaning it can push, it can pull, it can lift a lot things more efficiently. So when you have a gear reduction, you are going to have more torque, but less speed in a machine. Bigger gears are going to take more time as well as spin less rotations when the point meets because they have a bigger diameter and a bigger circumference. Remember, these gears are circles, so that's why they have a circle in them, but they use diameters and circumference. So let's move on to the next gear set. So here is the next gear set. So we have that green gear again that has 60 teeth. But hang on, we have a tiny metal gray gear and it has 12 teeth. So we're going to understand what kind of gear setup is this. Remember, we're going to say that the green gear is attached to the motor. So that is going to be the drive gear. That metal small gear is going to be the driven gear. So here's what's going to happen. The drive gear we said was 60 teeth. But the driven gear we said was 12 teeth. So there's got to be some kind of weird ratio. 12 to 60. What are we going to do about that? Well, they are both multiples of 12, and if we get that 12 down to 1, it's gonna make tons of sense. So we're gonna divide both sides by 12 and see what happens. 1 to 5. So our gear ratio is going to have 1 to 5. That is gonna say every time the green gear spins once, that metal tiny gear is gonna spin 5 times, making the machine and the gears a lot faster than they are. Remember, the green gear is part to the motor, and the metal gear is what's being driven, meaning the metal gear is going to spin more. The green gear is going to spin less. So what kind of gear setup is this? Yeah! It's an overdrive!
Shinkagear, 軌道確認。
よしレバーを一気に下げて超進化速度に到達させるんだ。
わかった。
超進化速度加速します。
超進化速度到達。
So overdrive gear setups are really, really useful if you want to make a machine that is very, very fast. That's because when the gears transfer energy, also they transfer speed and torque. So the big gear rotates once and the small gear rotates 5. That means the smaller gear is going to spin faster since it has to keep up with the much slower, bigger gear. The smaller the gear, usually the more rotations it needs to mesh up with the same place of a much bigger gear. So here's an example of an overdrive.